Hey guys, this video is going to be over dihybrids. We already crossed monohybrids in another video. If you haven't watched that, make sure you go back and watch that so that you can have the review over the steps that we need to know for this video, okay? But we're going to review them real quick, but make sure you watch the monohybrid video before you start watching this one. So again, the 4 rules that we're going to follow to solve dihybrid crosses are going to be: first, to determine the alleles of the parent; second, determine the gametes, or what alleles this parent can give to his offspring. We're going to find the combinations, which is the Punnett square, and then we're going to determine the ratios, genotypic and phenotypic ratios of that Punnett square. Now, we worked with monohybrids in the other video. This video is over dihybrids, and this dihybrids have to do with 2 traits. So instead of just looking at the color of the hair, okay, color of the hair, which is, let's say, big B, and we said big B was for black hair and little b is for brown hair, okay. The color of the hair, yes, we're looking at that, but you're also looking at the height of the organism. So it could be T for big T, which can be a tall plant. So T is for tall, little t is for short. So again, we're going to be looking at 2 traits: the height and the color of the hair. That's 2 traits, or it could be any other traits, right? The color of the eyes and the size of the ears, or the size of the feet to the size of the nose. It doesn't matter. As long if you're using 2 traits, you got to do a dihybrid cross. And a dihybrid cross is going to be a cross or a Punnett square where you're making a cross or a Punnett square that's a 4x4. So that is going to give you a total of 16 offspring. Okay, so that's a dihybrid. Okay, don't get scared about how big this is. If we follow the 4 steps, it's going to be a simple process, and you're going to get the right answer every time. Okay, so let's look at our practice problem. It says if a plant that is homozygous tall and smooth is crossed with a short and wrinkled plant, with which percent of genotypes will most likely be found in the first generation of offspring? So they want to know the genotypes, right? And we know that this is the key for, let me go back. This is the key for our alleles. And we know that parent 1 is homozygous tall. So homozygous tall, that means is big T, and homozygous smooth, which is big A. So that's parent 1. Parent 2 is going to be short and wrinkled. Well, in order to be short, you got to have both recessive alleles. In order to be wrinkled, you got to have both recessive alleles for that trait. Okay, so this is step 1, to find the alleles of the parents. Then we got to find the gametes, or the combinations that these parents can actually give to their offspring. And this is where you need to make sure you pay attention, and you need to practice so that you don't get this step wrong, because this is where a lot of students get points off because they forget how to distribute the alleles. And it's just distribution, okay? Or as sometimes they call it in math, FOIL method, right? You go from the outside, the first allele, and you go from outside to inside in the second allele, okay? So that gives us big T, big A. And then you use the same allele, but you go to the outside of the allele, so that's big T, big A. And then you use the inside, outside. So in this case, it's easy because we have the same gametes for all 4. So the 4 combinations that can give are all the same. And this one, if you can see that, is going to be the same thing, except that they're going to be recessive, right? So we distribute the alleles, and we can say that we're going to have 4 alleles, or 4 types of gametes that are going to be all recessive. So once we know that, then we can set up our Punnett square. And we know that our Punnett square is going to be a 4x4, okay? And there's our Punnett square, okay? And again, it doesn't matter where you put the parents, but we're going to grab this one and we're going to put it on the top. And we're going to write the first one, big little t, little a, little t, little a, little t, little a, little t, little a. And then we're going to grab parent 1 and we're going to put it on the side. And if we do that, then this is going to be big T, big A, big T, big A, big T, big A, and big T, big A. Now, look at the pattern, look at the square. Okay, we don't have to do the entire dihybrid. We did the first example I wanted to do was an easy example so that you could see that sometimes you don't have to do the entire Punnett square, because this one, let's bring down the t's first. Well, we have a little t and a big T, so we're going to go big T, little t, and then we have a big A, little a. Okay, this one is going to be the same. Look at the alleles, right? You look at this one, you look at this one, and they're going to be the same. Big T, big A, little a. And if they're all going to be identical, right? And that's just a pattern that you get when you have a dominant parent for both traits and a recessive parent for both traits. Okay, so that means all these are going to be the same. So that means that our genotypic ratio, which is step number 4, okay, it's going to be 100%. Okay, if he has a big T, you know it's going to be tall, so it's going to be 100% tall. And if he has a big A, you know it's going to be smooth, so it's going to be tall and smooth plants. And that's our genotypic ratio, and that's dihybrids. Okay, that's one of the problems that you need to be able to do. Okay, so let's do the second example. It says cross two heterozygous tall and smooth parents. So let's set it up first. Okay, so it says that parent 1, okay, sorry about that, says parent 1 is heterozygous. Actually, both of them are heterozygous, so that means they're going to be big T, big A, little a, and that's going to be big T, big A, little a. So that's both parents. This is step 1, and we know that because they're both heterozygous. Then in step 2, we're going to distribute, okay? Big T, remember these are two traits, so we go outside, inside, outside, outside. So that's big T, big A, big T, little a. This one we distribute again, and it's going to be little t, big A, little t, little a. So those are our 4 gametes. This one, the parents are identical, so we know it's going to be the same type of gametes that can give off, right? But if you're not sure, always distribute. So you go outside, inside, outside, outside, inside, 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 outside, and you can get the gametes, right? So now we're step 3. We got to set up our Punnett square, and I'm going to use another screen just to show you what we have, okay? So there are our parents, okay? That's number 2. And then number 3, step number 3 is to set up our Punnett square, okay? And you set up our Punnett square. It's going to be 4 by 4, remember that, okay? And we're going to have, so I already went ahead and put the parents on. It doesn't matter where you put them, again, as long as you keep them together. And in this case, I grabbed this 4 and I put them here, and I grabbed these other 4 and I put them on the top. Okay, so that's all I did. I set up the parents. Now we make our cross. And remember, you just bring the T's first, then the A's or G's, whatever letters you have, right? And put the capital letter in front, just because it makes it easier to read when you're reading your genotypes, okay? So that's what you should have so far. Just continue making your square. And when you're done, your Punnett square should look like this, right? And once you have it set up, then you can start looking for your phenotypic ratios, right? Or genotypic ratios, whatever you need. But let's look at our phenotypic ratio. Well, let's look at this one first. How does that one look right there? That one is going to be tall and is going to be smooth, right? Because it has both dominant traits. This one, since it has a big T and a big A, tall and smooth. This one, tall and smooth, 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 right? So that gives us 1, 2, 3, 4, 5, 6, 7, 8, 9. That gives us a phenotypic ratio to start off from. It's going to be 9 tall and smooth, okay? And then we're going to have the next one. Let's see, this one is tall and wrinkled, tall and wrinkled, tall and wrinkled. So that gives us, that gives us 3 tall and wrinkled, right? And then the next one is going to be short and smooth, short and smooth, short and smooth. So that's 3 short and smooth, right? And then the last one that we have is this one, this lonely one, which is the recessive one, which is one that's short and is wrinkled. Okay, and that would be our phenotypic ratio. And anytime you have two heterozygous parents that you're looking at, and they have two traits that you're comparing, then you're always going to have this ratio, 9 to 3 to 3 to 1. Okay, but you got to be able to set up your Punnett square, do your Punnett square, and then just to double check that you have the right information. Okay, so let's do a quick homework problem, one of your homework problems, and then we'll call it a day. All right, so this is one of the problems, and just asking you, what are the phenotypes of the rabbits that have the following genotypes? Well, we know that genotypes, okay, first of all, you got to know the vocabulary. Genotypes are letters, phenotypes are traits. So the genotype for this one right here would be big G, little b, little b. And we know that the phenotype would actually represent gray hair, and the little b would be red eyes. Okay, so that's one example. That's what you have to do. So go through all those and go through the phenotypes and look at the genotypes, give me the phenotypes. Okay, now on the bottom of the page, okay, we'll go ahead and start with this. Okay, you have to complete the entire Punnett square. Okay, and I'm just going to show you a couple, and then I'm going to show you how to start looking for this. Okay, but you got to look at the patterns that you see. Okay, so this one would be that's how that one would look, right? Because this one is all the same, and that would make all those offspring exactly the same. What do you think would be the ones that go here, since this one and this ones are the same? Okay, and then you do this one as well, right? So if you look at the pattern, you see that you don't have to do the entire Punnett square, because these are going to be identical to those, and this ones are going to be identical to those. So now that you know what the Punnett square is going to look like, now you can answer your questions. How many out of the 16 have fur and gray fur and black eyes? How many have gray fur and red eyes? White fur and black eyes? White fur and red eyes? You should be able to do that. Just look at your key and give me the answers. Okay, I hope this helped. Let me know if I can do anything to help you learn more about Punnett squares. All right.